Hi, welcome to this video about CYCLE 5, a new 6 HP oscillator module by Joranalogue Audio Design. CYCLE 5 is a really, basic or simple VCO, but it has a few tricks. After all, it's called the Vari-Wave Oscillator. And that's of course because we have variable wave output that morphs from sine all the way to pulse through saw waves triangles. In this video I will walk you through the basic wave shapes, how they sound, how they look. I'll demonstrate the pulse width modulation as well as the variable wave output and the modulation. I'll do some FM, I'll do some sync, and I will also show you how you can use this +5th switch here and how you can use the module as a fully capable LFO as well. Along the way you'll see we'll stumble onto some great sounds. Let's have a listen to the basic waves first. So this is a sine wave, as you can see on the scope. The red line is for later. Maybe I should turn it off. Let's go through the whole range. We're at audio rates, by the way. And we can go a little bit higher with this switch here. I'll explain how this can be useful later. Let's listen to the triangle wave. Now the saw wave, and you'll see and hear that this is a really solid saw wave. I really like powerful saw waves. I skipped one there, doesn't really matter that much. I'm just doing this to be complete. Now for the pulse wave with the vari-wave parameter. This is a shared control, by the way, for both the pulse wave and the variable wave output. But to get a 50% square pulse, you have to place it on, well, either this line or this one. When you have it at the center, it's I think it's a 90% square wave. So let's place it there, and let's go through the range. I'll talk about the variable wave output in a minute, well, in a few minutes, because we can do some unique things with that output. And I first wanted to cover the basics. So let's monitor the triangle wave. This is a gentle wave, but it has some harmonics. And let me demonstrate some frequency modulation. I'll be using a Generate 3 output here. I'm going to use the fundamental output of this module. I'll send it through the oscilloscope first, just for good measure, and then let's send this into one of the 2 volt per octave inputs on cycle 5. It's very nice that we have 2 of those. This is, well, you can use this for sending in a melody with the volt per octave standard, or you can just use these as exponential FM inputs, or both. Now, since there is no potentiometer for the FM, it's best to attenuate it beforehand. But with Generate 3 I have these nice potentiometers on the module itself. Should you want to use the core output, or well, another module that does not have these potentiometers, you can just go through an attenuator, select 2, mix 3, or any third-party attenuator that you have. You could also use bias 2 to attenuate the signal to half the strength, but well, it's nice to have a knob. And let's just play around for a minute with some relative tunings. I'll also be adjusting the strength of the FM with this knob. So that sounds rather nice. So should you want to sequence this sound, you can do this, well, several ways. Let me show you a few. So you can go, well, you can go with your sequence right now. This is just some random stepped sequence that I will quantize. I'm just sending it into the volt per octave input on cycle 5. Of course, now our modulator, you can also see this on the scope, is not following the same notes. And this can sound interesting, but maybe you want to keep the tonal quality of this. Well, then you should also sequence your modulator with the same string of notes. And even though this still sounds dissonant, I think you'll agree that this sounds, well, more coherent in a way than this. You could also just sequence the modulator . And what you then could do to tie things together is use the reset input on cycle 5 to sync cycle 5 to the modulator. Now I should maybe use another output here. And now when I change the tuning on Geroid 3, the problem here is that my ranges on my stepped sequence, the stepped CV, is way too big. So we are getting into LFO territory with cycle 5. So I just narrowed it down a little bit by turning down the sliders for the stage of step 8. Let me remove the sync signal. So this is just us sequencing the modulator, not the carrier, which is a weird thing, a weird way of doing things. Well, you can make this work by just using the reset input. This is mentioned in the manual of Cycle 5, by the way. It would of course make more sense to just sequence your carrier, which is cycle 5, and then maybe sync your modulator to your carrier. Well, that changes things a lot. But as you can hear and see, there's all kinds of interesting, strange noises to be found there. Let's remove these connections. Let's remove the modulator for now as well. And let's go back to the pulse wave. And well, we don't have to just manually change the pulse width. We can also use the shared CV input here. I say shared, I mean shared between the pulse wave output and the variable wave output. Let's patch a self-oscillating filter 8 in low or LFO mode through select 2 here. Just so I can attenuate the level of the LFO a little bit. And let's listen what happens when I send this into the vary input. So you can hear we have PWM. Now if I remove filter 8 from select 2's input for a moment, I can just use it as a static offset. And you'll see something peculiar happen. Let me set this in the middle position. You can go through the complete range of this knob with 5 volts of CV. Let's put it in the center position and let's add a little bit of voltage with select 2. Well, maybe I should send it through the scope so you have some kind of clue about what the voltage is that I'm sending in. Here. So this is close to 0. And then when I turn it up, keep in mind that 1 square on the scope represents 5 volts. So that should be about the end of the range because, well, we set this knob in the center and this knob is an offset to whatever you send into the CV input. So this is at 2.5 volts, well, so to speak. And you can see by adding more, you just push the PWM wave through 0. So it's best to take some care in attenuating your signal, just so you don't get audio dropouts, well, unless you want them, of course. Maybe I should turn this knob to the left. And let's now see what adding voltage does. You might think that adding voltage widens the wave and keeps adding it, keeps widening it until it's gone, but well, actually that's not what's happening. You can see that actually between 0 and 5 volts it cycles between a 50% pulse wave and a 90% or duty cycle pulse wave. It cycles between those a few times. So this is different than most PWM modules. Let's send filter 8 back through here. This CV input is bipolar, by the way. It accepts negative voltages, so it should be no surprise that when we put this knob completely to the left and we add negative voltages, that we, well, go into 0 or inaudible as well. So set it somewhere here, or maybe in center position, and then you have nice PWM that you can use for everything you want, but I like to use this for nice basses. If you mix this with, well, maybe a saw wave, let's try it. Let's try sending a saw wave into your right ear. Right now we're listening in mono, but as soon as I connect a second signal to transmit to, you're going to be listening in stereo. Maybe let's add a sequence. Well, you shouldn't really mix this in stereo, but well, you can. It sounds rather good in stereo as well. Let's increase the rate of the source or the modulator for the PWM. Maybe let's increase the level as well. So it's a little bit peculiar, but you need to take a little bit of care with the levels there, so you don't go through 0. And well, I promised you to tell you a little bit about this 5th switch here. So let's go back to the triangle wave and remove the sequence. Having that perfect 5th, this is 7 semitones by the way, is, well, very useful in a number of cases, especially the one I will be showing you. Usually my VCOs are not tuned, and well, this can be a little bit annoying if you want to, well, create some music with a bass line and chords that don't sound all out of key. And then of course I have to tune all my VCOs, but I don't really like to use the tuner on data because, well, then I have to go out of this screen and press buttons. I really don't like it. So what I have been doing since this prototype is in my case, I just connect the second VCO and I tune it by ear to whatever cycle 5 is at. The combination of the octave switches and the fine tune makes it really easy to use it as a reference because, well, it's always in tune. As long as you set it to the center here, it should be a C. So then when I want to tune my VCOs, I just, of course I'm already too high, I just use cycle 5 as a reference, and I do this by ear. So I think we're pretty much in tune there. And then what's cool is when you send in a melody to both VCOs, You can use this fifth switch to create something really, really nice. Let's remove these sequences. By the way, the range of this fine tune is about 7 semitones. This is for the complete movement of the knob. So, well, 3.5 down and about 3.5 up. So together with the fifth switch here, there should never be a pitch that you cannot reach without CV. And let's now listen to the variable wave output of cycle 5. It's easy to tell, but in the center position, this gives us a saw wave, and I mean center position of this knob here. Also the center position of the CV range, or the voltage range for the CV input, which is still 5 volts. When we turn this knob to the left, we arrive at a sine wave. Let me go through them in this direction. So sine wave morphs into a saw wave. We go through a triangle wave and this kind of interesting shark tooth wave. And we have these in-between shapes that I really, really like. So saw wave in the center. And then 50% duty cycle pulse wave. Really nice shapes here in between, and then from there on the pulse wave just widens or narrows, depends how you look at it. So you can go really narrow / wide with this knob. Of course you want to modulate this with CV, so let's demonstrate that. Again, I'll be using filter 8 here through select 2 to attenuate the signal a little bit, because again we can go beyond what we can hear. So let's connect this slow sine wave LFO to the variable wave CV input. Increase the level of the LFO a little bit. By the way, I want to show you immediately, don't be afraid to modulate this parameter at audio rates. This is really something interesting. Then we can again add a sequence to cycle 5 and to our modulator as well. At this point, cycle 5 really becomes a beast. What you could also do is use some stepped voltages to modulate this parameter. I should take this output here. And let's increase the range of step 8 again. I should do this differently. Let's just keep the sequence going. Decrease the range again a little bit. Then use the same sequence. And then we have a slightly different shape for every note. You could also use this variable wave. Let's remove the sequence. This variable wave parameter as a kind of filter, or to achieve like a filter effect. So if we put it in this position and then we maybe connect the output of contour 1 here. I'm going through select 2 again just to keep the ranges down a bit. And let's trigger contour 1 with the step output on step 8. And then when we, maybe I should run this through the scope again, yes. Let's zoom out a bit. And then when we connect this signal, which is probably way too hot right now, and when we connect this signal to the variwave input, you can see that we have kind of a filter effect going. And this is possible because, well, we go through the range and the waves get harmonically richer the more we move this parameter to the right. And this is also mentioned in the manual, by the way. It's a great tip, I hadn't thought of this. Let's connect the random sequence again. As you can hear, this sounds, well, really unique. And maybe let's reintroduce some FM coming from this generator 3 here. I just connected the sequence to it as well, so it's following our sequence. That's interesting. Can I use the sync trick at the same time? I think this sounds really interesting. I think that's all the basics about CYCLE 5 in audio rates. Let's now have a look at a few ways you can use CYCLE 5 as an LFO. Here we are. In the meantime, I changed up my patch here. And I also flicked this switch on CYCLE 5 into the bottom position, which is the low setting. And you can see the output of cycle 5. I connected the sine wave. You can see it on the scope. We are indeed in LFO territory. To demonstrate this, I made a sound with 2 generate 3s. You can see one of them here on the left of the screen. I'm doing some phase modulation with the other generate 3 as a source or as a modulator. And then I'm sending this sound through filter 8. I'm using the bandpass output here, and I'm using the BB plus N. I forgot the complete name of this band reject. I don't know. I tried different outputs here to find which one sounded best to my ears to feedback patch into the linear FM on filter 8. Well, let's open this up a bit. Well, this sounds pretty nice and gnarly. Without the linear FM, it sounds like this. So this is just the result of the phase modulation. And then when you feedback patch the outputs, well, I chose this one, you get this nice, more saturated sound. Apparently I accidentally touched a knob here, so the sound has changed. Anyway, I want to modulate the filter with LFO from cycle 5. So let's connect this to the exponential FM input on filter 8. And you might be wondering how this is going to work, because you don't have a continuous course control here. Well, the nice thing about this is every time that you go up an octave, the frequency of the LFO is doubled as well. The fine control has quite some range here in LFO mode. As you can hear, and we still have the +5th switch here. It's pretty clear to me that the LFO just follows the volt per octave standard here. So everything that was true for cycle 5 in VCO mode is exactly the same in LFO mode. It's just a lot slower. So yeah, we can do this with a triangle and with the saw wave, which always gives these kind of decay envelope type effects. Then the pulse wave. Let's use this pulse wave for something that I used to do all the time. I always liked polysynths, or well, monosynths, but I'm talking about like synthesizers with a keyboard. Is using a square wave to modulate the pitch. But I have, well, since I have 2 VCOs running, I have to mult this. I can do this with link 2 and just send this to the exponential FM input on both generates. And then when you turn up the frequency, you get these cool effects. But maybe I should fine-tune these. And depending on your settings, of course, you can get, well, a two-note melody. Let's go up. You can get into like chiptune territory. Anyway, enough of that. I just wanted to try this. And why not? Well, let's switch to the vary wave. This should be interesting. So, by the way, we are still, or again, modulating the frequency of the filter here, which is filtering a complex sound coming from two generated threes. I have to modulate this parameter. Let's use a stepped output of step 8 to modulate the vary parameter. Now, as you can hear, it's a little bit chaotic, and this is because the frequency of the LFO has really no relationship to the frequency of, well, the sequencer or stepped voltages, if you will. We can get it to sound good by just fine-tuning it by ear, but you can as well reset your LFO. I'm just going to use a pulse output of step 8, which acts as a clock. And then if I turn down the frequency here a bit, well, just as I thought, this sounds rather interesting. Maybe let's change up my sound here a little bit. This is really nasty. I love it. This is nice. Okay, enough of this. Let's change up the sound again. Let's go for some through 0 FM. This sounds great as well. Now I want to use the output of cycle 5 to modulate the frequency of my VCOs. But well, to be able to attenuate both of them exactly the same, I'm going to run them through select 2 first to attenuate them. I realize you cannot see this, but well, I'm telling you. And then from select 2, let's connect it to link 2 to mult it. And then I can go into the volt per octave inputs of both VCOs. Let's now set this to a saw wave, which is the center position of this knob. And let's connect the pulse or clock output of step 8. It's really called the step output, but well, it's a clock. Let's connect it to the reset input again. You should be able to see the reset happening. Let's change up the wave. And why not use a second output here of cycle 5 to modulate the filter as well? Maybe invert it. And maybe instead of using an output of cycle 5 to control the pitch here, let's use a stepped output coming from step 8. Let's change up the modulator for the linear FM. And let's modulate the amount of linear FM with an output, well, variable wave output of cycle 5. And of course we can also use the volt per octave inputs here for frequency modulation. Let's take a stepped output here again and run it through data quickly. And let's connect it to the volt per octave input. This is a little bit extreme, but I really like it. Enough of this. Let's disconnect everything so I can see what's happening. Again, there's a little bit of chaos here going on, and it's not going from orbit 3. Yes, so let's try making some noise with generate 3. If I remember how to do it, it's by connecting the even output, I think, to the phase input, and then turning everything up. Or was it the FM? No. So this is still going through filter 8 on the bandpass setting. Well, maybe I should use a low pass output for what I want to try here. So let's have a look at the pulse wave. So you can use pulse waves as clocks. And to demonstrate this, I will use the clock pulse to trigger contour 1. You should see that contour 1 follows the tempo of cycle 5. And if we now take the envelope out here and patch it to the exponential FM input on filter 8, we should get some kind of hi-hat sound. There. And if we now modulate the vary wave parameter, if you remember, this is a shared control for both the pulse wave output and the variable wave output. When you're listening to the pulse output, it changes the pulse width. Let me see if I can use some feedback patching here. From this to there. So there you see, if you use, for example, the sine wave output and you patch it into the vary wave input, or the CV control, in this case for the pulse width, you can end up with a clock that swings. Of course, if you add an attenuator between this, you have more control, but well, as a proof of concept, you can see it works. I wonder what happens when we use the triangle wave. Oh, that changes the swing a lot. And maybe the square wave. No, I meant the saw wave. This doesn't seem to do a lot. And what about the vary wave? That probably depends on the setting here as well. So, well, my first guess was the best one. Let me try and use the rise output here on contour 1 to use as a clock for step 8. And then I should be able to well, connect a VCO to filter 8 second input. And if I then connect a sequence coming from step 8 going through a quantizer to this first generate here, which you cannot see, you can see and hear how we used our clock to sequence step 8 and to trigger contour 1 to kind of make a hi-hat. I'm sure I could make a groovebox patch from this in some way. Anyway, I think I can show you 1,000 things that you can do with CYCLE 5S and LFO, but I just wanted to do a few things to demonstrate how it is to work with the module in low mode. This is going to be it for this video about CYCLE 5 by Joranalogue Audio Design. I hope you enjoyed it somewhat, and thank you for watching. Bye!